So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on junction diode. So let's begin with the worksheet. So here is the worksheet on junction diode. The first question is how junction diode is made. So for making junction diode we use a P wafer, dop it with N-type impurity from one side which leads to PN junction, and using that junction we make junction diode. Next question is symbol of junction diode. So this is the symbol of junction diode. This side represents P and this side represents N. Next is biasing of a diode. So diode can be biased either in forward or either in reverse. The next question is what is forward biasing. So when point P is connected to the positive terminal and N to the negative terminal of the battery, the biasing is called forward biasing as shown in the figure here. Next question is what is reverse biasing. So in reverse biasing, P is connected to the negative terminal and N to the positive terminal as shown in the diagram over here. Next is we are being given a question comprising of two diodes D1 and D2. The question here is which diode is forward biased. So the trick here is just make the current to flow. So if direction of arrow of the diode is in the direction of current, it is forward biased, while if it is reverse, then it is in reverse biased. So we can see that D1 is forward biased. So which one is forward biased? D1, because direction of flow of current is in the direction of arrow indicated by the diode. Next is which diode is reverse biased. So D2 is reverse biased because the direction of arrow of the diode is in opposite direction to the direction of flow of current. Next is R equivalent. So this will provide infinite resistance and the total resistance will be 10 plus 30, which is equal to the 40 ohm. Next is current in the circuit. So current is V by R. Voltage here is 50 volt. Resistance is 40 ohms. So that is 5 by 4 ohm. Next is current through I1. So I1 is this will be an open circuit. So no current will flow through this. So I1 will be 0 here. Next is I2. So entire current will flow through I2. So I2 will be 5 by 4 ampere here. Next is power supplied by the battery. So power supplied is I square into R equivalent. I is 5 by 4 whole square, R equivalent is 40. So after calculations we get 62.5 watt. Next question here is IV characteristic of PN junction diode. So the characteristic is like this. Initially current is 0 and after cutoff voltage is reached, I increases exponentially with V up to a certain limit, and in the reverse bias it's just like this. Next is junction diode as a half wave rectifier. The half wave rectifier means a circuit which rectifies only half of part of this circuit. So this is a transformer and it creates an input voltage which is positive during one cycle and negative during another cycle, and output we take over here and input is applied over here. So if input is like this, so we can see that during first cycle input is positive. So if input is positive, then diode will be in forward bias, so it will conduct. So there will be output across VO, while during the negative cycle diode will be in reverse bias, so there will be no flow of current through this and hence no current through the load resistance, and hence output voltage will be 0. So the output here will be like this. Here output will be non-zero, then output will be 0, then non-zero, then 0. So since it rectifies only half of the circuit, we call it as a half wave rectifier circuit. Next is junction diode as a full wave rectifier. So in this we use two diodes, D1 and D2, and a center tap transformer. So input is here, output is applied over here, and suppose that the input voltage is like this. So this is positive during first cycle, then negative, then positive, then negative. So what will happen is during the positive cycle, this D1 will be forward biased, so it will conduct. D2 will be reverse biased, so it will not conduct. During the negative cycle, D1 will be reverse biased and D2 will be forward biased. So in both the cases, there will be output through the external resistance R. So its output will be like this. So since it rectifies in both part of the cycle, so this circuit is called the full wave rectifier circuit. Next is frequency of output in half wave rectifier. So you can see that input is like this, so output will be like this. So you can see that frequency is same in both the cases, as both graphs repeats after the same time interval. Next is frequency of output in half, sorry, it should be full wave rectifier. So you can see here the frequency of this curve is double of this because it's repeating after time t, but this graph is repeating after time t by 2. So frequency of output is doubled over here. Next is what is zener diode. So zener diode is shown like this. It is used in reverse bias to save devices from increasing current or increasing voltage fluctuations, you can say. So it is used as a voltage regulator. Next is how zener diode is made. So for making zener diode, first thing is depletion layer is very thin and high doping is made, which results into very high electric field strength, which is of the order of 3 into 10 raised to power 6 volt per meter, which causes the breakdown to happen and voltage remains constant and the current may increase. Next is what is LED. So LED is the light emitting diode. Next is what is solar cell. Solar cell is a device which converts light energy into electricity. We all are aware of this. Next is photodiode. So photodiode is a device to detect optical signals. Next is why zener diode is used in reverse bias. So it is used so that voltage across zener diode remains constant with time. So you have seen that these physics worksheets are designed to optimally prepare you for exams, as these contains questions from the very basic level, which are generally not clear to the students, and when they solve a good question, then there is a use of these small little steps. So from these worksheets, we aspire to develop a mechanism by virtue of which you can improve your problem solving skill. And it starts from the level 0, so that you can optimize your time and energy and fetch good results. Thank you and have a nice day.